Hello, let's start with our today's DSA using this amazing visualizer by ChaiCode. Use this link to get a 7-day free trial. Let's start with our DSA today. Today we will solve the problem sort coloring. So the problem says given an array of object colored 0, 1 or 2, sort them in place so equal colors grouped in a order identical in a single pass. Okay, so this is our array. We have to make sure the array after the operation looks like just the sorted ones. You can clearly see this is the input array, and after all operation we get this output array. And the question is, how could we do this? We can easily use a sort function. So if we go to lead code, you can clearly see that you must solve this problem without using any library sort function. But if we use any sort function here, like I am using the C++ sort function, so this function completely works. And this function takes a time of big O of n log n. Okay, even you can use a merge sort algorithm to sort this whole array, but we have to do this in place, like in place, so that the color group identical in a single plus. This is the tab. So how could we do this? Do the sorting. So this is our array. So suppose let's take three variable. One is 0, to take the count of 0, another one is 1 to take the count of 1 in this array, another one is 2 to take the count of 2's in the array. We just take it. Next, just traverse it from start to end. First we get here a 2, increase it by 1, again get a 0, increase it by 1, we get a 1, increase it by 1, we get a 0, increase the 0 by 1, so this will be 2, we get a 1 in the next, increase it by 1 and it's become 2, we get a 2 here, increase it by 1, we get a 0, so increase it by 1. Now currently the z number of zeros are 3, number of 1 are 2, number of 2 are 2. Okay, now just take this array and put the zeroth at the first, and then second a 1, and then third 2. How? Just take the array and just replace the first three element with 0. Okay, then 1, replace the next two element at 1, then 2, replace the next two element at 2. Just replace in the current array or the input array, and we get it. So we can use a 3 variable, or we can use an array of size 3. We can take an array of size 3 initialized with 0. Why? Because the index is 0, the index is 1, the index is 2. So easily with the help of index we can calculate the number of values in the array of that index, because the array only contain 0, 1 and 2. Okay, let's come and visualize here. First we are given an array, we take a count array that is 0, 1 and 2, 0, 1 and 2, just traverse the array. We got a 2 here, so we increase it. Then we got a 0, so we increase it. Then we got a 1 to increase it. Then we got a 0, we increase it. Got a 1, increase it. Got a 2, increase it. Got the 0, increase it. We got it. Now again put another loop here. Just replace every element first 3 0, then 2 1, then remaining at 2. Okay, and we just return the array or be void. So we write down the pseudocode for it. Okay, so take a count array which is an empty array initialized with 0 and have only 3 index, 3 size. Okay, so now loop on the array, on the array or the input array to check every element, to check every element. Okay, so that would be count of arr of I plus plus. So what it does, it goes to into this array, take the first element, it is 0, so increase the count 0, so it will increase this by 1, then get a 1, increase it by 1, then get a 1, increase it by 1, get a 2, another 2, increase it by 1. Okay, so we get all our values here. Now just replace it with the values in the existing array. So take another for loop. This loop start from 0 to 2. Why? Because we loop through into this count, into the count. So while count of I is greater than 0, at this point we just take array of, and at the starting take an index to traverse the existing array. So I take idx starting from 0, array of idx plus plus equal to I. Yes, and just count of I minus minus. It traverses into this initial or input array for every element on this array. We replace it with the counts value, like every time. Okay, so just evaluate it. Let's see it here. Yes, we nailed it. Just copy this, paste it here. Okay, this is the pseudocode. Now write the actual code based on this pseudocode. So take the in, that is nums dot size, take a vector of integer of count of just 3 size, initialize with 0, traverse the array, just put count of I plus plus, increase it. Now take another index, traverse the count array, while count of I is greater than 0, then simply nums of index plus plus became I, and count of I minus minus. So it is a void function, so you don't have to return anything. Let's submit it. Yeah, it's all. Let's move with our next approach, that is better two pass for a partition approach that is also in place. Okay, let's go with better two pass swap partition approach. In this case, what we will do, that is take it. What we will do in this case is, first we traverse this array and put all the 0 to the starting 0 0 0. Okay, then in a middle portion we can take a many random elements. Okay, and then we again traverse the array and put all the 2's at the end, and in this case we will make sure the 1 should be in the middle, and it will automatically happens. We get a sorted array in place. So let's visualize it. So first we got a range with all mix like 0 1 and 2. You can see a great line here to mix all the area. Okay, now just put a pointer to the starting. If we found any zero, just swap it with this right pointer. So I will move till the end, and if we find any 0 at the ith index, we just swap it with right and move forward right. So in this case we can't find any 0, so we don't swap it. Okay, we just move forward with the I. We just take it, it is not 0. Okay, move forward. Let's see, currently ith index has a 0, so it is on 0. So what we have to do, we have to swap this and increase the right and the I both. So we take those element and we swap it. So this portion is now 0. This portion is only for 0. And this portion is for mix 1 and 2. Okay. So then again we got here, we take it like it will say we increase that. We increase the I here. We take it 1. Don't do anything, increase the I. Again we got a 0. Swap it. Swap it. We increase the 0 region and increase the both I and right. It is 0, no. It is 1, yes. So it is not 0. So increase it. It is 0, no. It is 2. Increase it. It is 0, yes. Swap it. Now see, we got a region that is only for 0. So all 0 are sorted in this region. Now the whole point is to make this remaining non-zero 1 and 2 mix. In this region we have to take all the 2's to the end. All the 2's to the end. So previously remember the right at this third index. Okay, this in this third index. So in the next pass we'll take 2 pointers. One pointer at the right pointer, that is in the third index, another pointer at the end. We just took this is I. You can clearly say this is I, and this is a back pointer. So whenever the I is greater than or equal to back, we run a condition. If we get ith index value as 2, we just swap it with back. If we get any value at the ith index as 2, we swap it with back. Let's see it. We take it, we swap it. In decrease the back, increase the I. We increase the I, increase the I, increase the I. It is 1. Okay, increase the I, increase the I, and it is equal and it is 2. So don't swap it. The back is now less than I, so we got our array. This is our approach. Okay, so let's write the pseudocode for it. We use a function that takes an array, take a pointer, right, it is at 0. So a for loop for I starting from 0 to n minus 1. Check if arr of I equals 0. Then simply swap it with arr of right. Arr of right, comma arr of I. Okay, swap it and increase the right. Okay, increase the right and we automatically increase the I using this for loop. So the if ends here. So after the loop completely runs, we will get a region which is take all the 0. Okay, so in the next case we take another pointer like I, which is on the right index, and we take another pointer as back, which is on the last index. Okay, take a while loop, I less than equal to back, if array of I equal to 2, then just swap it with array of back. And decrease the back, and on the else condition just increase the I. Okay, this is our pseudocode. Let's just evaluate it. Yes, we nailed it. Let's write the code now. This is the pseudocode. Just read and write it. Okay, take a right, take okay. Take a right pointer at the start of 0 for int equal to 0 I less than n I plus plus. Just if nums of I equals 0, then just swap it nums of I comma nums of right, and just increase the right. Okay. Right. We just, in this case, we just put all the 0 at the starting. We just put all the zeros at the starting. Now put all the 2 at the end. Okay, so take another, like I take I from right and another pointer as back equal to at the end index. So while I less than equal to back, at this point what we do is check if nums of I equal to 2, then swap it with the back. because we want all the 2 at the end. So swap it with nums of I, comma, nums of back. Okay, and decrease the back, and if we can't get it, just increase the ith pointer. If we can't get 2, so if we can't get 2 here, so that means it is a 1, and it is a 1, so we just easily increase the I. Maybe you understand why we don't increase the I here, because if in the middle there is a 2, like this is the condition, let's put another 2 here, another 2 here, and remove one index. Okay, so first, in the after the first pass, the 0 will be here, the 2 will be here, the 1 will be here, the 2 will be here, the 1 will be here, the 2 will be here. Okay, so we put all the 0 at the starting. In this case all the 0 at the starting. Now the right pointers are actually here, or the ith pointer, the I which we take, and this is the back, let's take it B. Now swap this, we get the same array again. Okay, so if we swap it, we got the same array again. So the I will be here, the I will be here, but the back just got 1 point here. Now because we just swap it here, so these all are 2 and 2, so the array will be same. So now we can swap this 1 and 2 here again in this loop, in this in here. But if we increase the I into the next index, then we just put a 2 inside the middle. So for this case we only decrease the back here, and now in the next case, in the next portion we will get 0, 1, 1, 2, 2, 2. So this will be our next condition. We just swap it in this 2, and the 2 goes at the end here, and the 1 goes here. So we just segregate 3 portions, 0, 1 and 2. Now increase the I after this swap. That's why the I is in the else condition, not in the if condition, or not in general. Let's submit it. Yes, it works. It will take a big O of n time, big O of n, big O of n. It will take a big O of n time. Like first, it will for this condition it is properly big O of n and dependent on the right. So that would be n minus right. If we submit it, then it will be 2n. Approximately the complexity will be big of n, and the no space is used. Okay, now the most optimal solution, which is the Dutch national flag solution. Okay, so the Dutch national flag actually have only 3 colors. So if we just search it, this is the Dutch national flag, only 3 colors. So the algorithm on this name of, because we have to sort only 3 elements, so we just have these 3. Okay, so the name was Dutch national flag, and the Dutch is Netherlands, so it will put as Dutch. So for this case we have to take something. Okay, so let's take some ranges, like we start with 0, a whole lot of range of 0, then many ones, okay, then two here and many twos, okay. And in the middle, this portion, we have random values between 0, 1 and 2. Let's suppose this is a series, okay. We have at the start, this portion is sorted, this portion is sorted, okay, and this portion is not sorted. Actually, this portion is not sorted. It has both 1, 0, 1 and 2. So we have to make sure that this portion becomes sorted so that our whole array becomes sort. Okay, so for this portion we have to take. This portion is not sorted. So let put 3 pointers. Okay, so it is the 0th index at the starting. It is the nth index, n, or the size of the array, or n minus 1 to be precise, n minus 1. Okay, so let's put 3 pointers here. Okay, one is low at this index. At the first one, we'll have, okay, let's take a L here, or low. Another pointer, that is the last index of this unsorted portion, that is high. Okay, and one portion, that is the first index of this not sorted list, that is mid. Okay, now in this algorithm we have to check for every value of mid in this non-sorted portion. Okay, for this, just let me copy this. This is our portion. Now we have to check the value of this array of mid. Okay, so what could be the array of mid value? It could be 0 or 1 or 2. The value of this index always in between these three, 0, 1 and 2. 0, 1 and 2, always. So what happens when the value of array of mid is equal to 0? The element we get is 0. What? So the mid minus 1, this is mid minus 1, this element. So mid minus 1 is 1 and the mid is 0. So it is not sorted. So where I can put this 0? So let's suppose this is 0. Okay, this is 0. So where I can put this 0 so that the array becomes sort. Forgot about everything, all the non-sorted part, all everything. Let's suppose everything is sorted. Only this 0 is here in the array of bit. Where should I put it? Identically, we should put it in between them to make it sorted, because 0 is here, 1 is here in between them, but we can't put it here. What if we just swap it with this low value? Because this is 1. If we put 1 here, so 1 and 1, and the 1 at the low is index. So we just put the 0 here, and the whole string becomes 0, 0, 0, 0, 0. This becomes 0, and this becomes 1. So now the whole string is sorted. Okay, simple. And after that we just increase the low by 1 here, also increase the mid by 1 to the next index to be sorted. Okay, so if we go here, just swap it with, let's suppose a, I just take a for simplicity, a of low comma a of mid. Just increase the low and increase the mid so that it will properly point for the next index. Okay, now another value of array could be 1. The value of array could be 1. What we can do when the value of array is 1? Just take it. Just give me a minute. Copy paste this here. Just 3 times copy paste it. Let's suppose the value is 1 here. Forgot about everything which is sorted, not sorted, everything. The value is 1. Is it in a sorted position or in a correct position? Yes, because the previous value is 1. So just increase the mid. Just increase the mid because all are sorted. The one is at its correct position. Just increase the mid. So for this case, just do mid plus plus. And the last case, that is if it is equal to 2, what we will have to do? Array of mid is 2. Okay, so where we can put this 2 so that the array is sorted? This is 2, this is like high plus 1 index, so in between them, but we can't put in between them, but we can put it here in the high index. In the high index we can put it here. Just swap it and decrease the high so that it point to the next array. So just swap it a of high with a of mid and do a high minus minus so that we can put it in a right position, and that's it. This is actually the Dashnasal fag algorithm, but for the normal array at the starting we have to take these three conditions as low would be at 0, mid also would be at 0, and the high at n minus, okay, n minus 1, because we are given an unsorted array, so low could be here, also mid could be here because we have to sort it this portion. So let's visualize it. First we take 3 pointers. The whole area is now unprocessed, which we called here unsorted. In this, like here, we just call it at unsorted. This whole area, we'll just take first this whole area. We take this whole unsorted area, unprocessed here, unsorted. So low at 0, mid at 0, high at the end index, till mid is less than equal to high. So what is the mid's value? Mid's value is 2. What happens when we have mid's value equal to 2? Okay, let's just put all of this at the bottom. When mid value is 2, we swap it with the high value and reduce the high. So it should be swap with this 0 and the high should be 1, reduced by 1. We make that, we swap it and the high would be 0, and after the high all are 2 region settle down in this image also. After the a high all is 2, all is 2. Let's again go there, again check, it is 0. What if it is 0? What we did when it is 0? This is the condition which we provide. Swap it with array of low and just increase the low and the mid. So swap it with this and increase the low and mid. Now from 0 to low minus 1 all are 0 region. Let's see it here. From 0 to L minus 1 all are 0 in this region. We got it here also. Now check, it is again 0. What we have to do? Just low plus plus mid plus plus. We did it here. So this is the 0th region, this is the 2 region of 2, and this is the unprocessed region which you have to process, or the unsorted. So now this is 1. What we have to do when we get it 1 here? Just increase the mid. Why? Because it is already in a sorted way. So just increase the mid. Increase the mid by 1. So increase the mid. We just increase the mid. Now this is 1 region, this is 0 region. So we get 0 here. Just put this. Swap it with the mid and increase the low. Swap it actually with the low. Increase the mid, increase the low. Just put it, swap it. Okay. So this is now the 0 region. This is now the second region. This is the 1 region, region of 1, and this is the unprocessed area. Take the mid. Now the mid is 1. Just increase the mid, and highs and mid is an equal. So the last portion, check it, it is 2. Swap it. If it is 2, what we have to do? Swap it with high and high minus minus. If we swap it with high, we again at the same position, and high, now high is less than mid, and we have to stop it. This is the algorithm. Now just write it. Function ARR, take a low at the starting, also at the starting, and high at the n minus 1 or the last index, while while mid is less than high, less than or equal to high. So when mid is less than or equal to high, we just have to check if the value, what is the value of mid. If array of mid equal to 0, then what we have to do? Just swap it with the low. ARR of mid with ARR of low. Just swap it and just increase the low and increase the mid. Okay. Now else if ARR of mid equal to 1, just increase the mid by 1. Okay. And in the else case, that's mean it is now the array of mid is 2. Just swap it with array of high with array of mid and just reduce the high by 1. Okay, this is the pseudocode, and let's evaluate it and let's check it it is right or wrong. Okay, the initializer of high should be correctness to n minus 1, where n is the length of the array. Ensure the high is set correctly. Okay, let's check it. The swap operation for the case when array of mid is 2 is not correctly implemented, it should be mid with high, but the mid should not increment immediately after the swap. Instead of it, it should decrement high. Okay, we have to return its cases other arrays. We don't have to do this. It should be okay. It should be okay. Like in the if is here, the else if is here. It should be okay. Why it give a wrong answer? Array of mid is equal to 1, so we increase the only the mid. Else if array of high equal to 2. Okay. Maybe this case. Because it is a pseudocode, we have to maintain something. And at the end, just return the array. Okay. So just okay. The high should be n minus 1, but not clear. Okay. Acha. Leads to incorrect result. The algorithm does not handle array. Yes, yes. Just check it. I think size of the array and it should work. It okay. The swap operation for arrays mid to should be swapped with high, but the student has reversed. What? This should okay. Maintain the consistency. Code consistency. For this case, the mid is at the starting. So this case, I think this mid should be at the starting to maintain the code consistency. I think this should be the case. Yes, that is the case. Maintain the code consistency. Now just write the code for this. Okay, this should be okay. Let's int n equal to nums dot size o equal to 0, mid equal to 0, high equal to n minus 1. Okay, now while mid is less than equal to high, then if nums of mid equal to 0, for this case swap it with low, swap it with nums of mid with nums of low, mid plus plus low plus plus, increase it. Else if nums of mid equal to 1, for this case just increase the mid, and the else for the 2 swap it with high. Nums of I or nums of mid is swap with nums of high and reduce the high. Yes, I think we don't have to return it because it is a void. Just test it here. Let's see. Okay, okay. It should be a spelling mistake. It's working. Okay, it's work. So for this case, we all just traverse the array once, big O of n, not two times, not three times, only once, and we just change it in place. So the time complexity for this code become big O of n, and the space complexity become big O of 1. And we solve the sort color problem here. Thank you. Thank you very much for watching it. Use this code. Use this link. Use this link to get a 7-day free trial on this amazing platform on dsa.chaicode.com. Thank you. Thank you very much.